Okay, the purpose of this video is to help you set up our red column when doing a protein prep. So once you get this video, we will already have conducted in our protein prep the running of our white column, which is an anion exchange column, separates proteins on the basis of charge. And we have collected fractions from our fraction collector, and then we have combined them, and they contain carbonyl reductase enzyme based on their activity. And in that pool, then we will be able to put it through this last step, which will take the protein from probably, I don't know, maybe 75% pure to pretty much above 95% pure, which is good enough for our studies. So that's what we will be doing. So step one is before you do anything, you'll take about 1 to 1.5 milliliters of the white column fractions that have been pooled, and that pool we'll save that in one of the snap cap little microcentrifuge tubes, which, unless things have changed in the lab, which I don't think they have, if you're facing the spectrophotometer, it should be about the leftmost set of drawers, about the third one down. But you'll put it in a snap cap tube and then set in our cooler, which is that glass stored refrigerator. Okay, and we save that because it's good to have some protein around to use as positive controls for activity studies, especially like if I'm training people to do the assay for the first time, to learn to have something that we know is going to work. That's what we're going to do. So then the second part is we load the pool onto the red column. Now, this part I want you to pay attention to, because typically our collected pool will be in kind of about 125 to 250 milliliter Erlenmeyer flask. And those can be really tippy. And so you have to, what we want to do is you'll take that Erlenmeyer, okay, and you will go and find a bigger beaker that it can easily sit in and set the Erlenmeyer in that beaker. And make sure it's a bigger beaker. And that way, if for some reason the Erlenmeyer tips, it's only going to spill its contents into the Erlenmeyer, thus preventing us from losing everything. Okay? So once you've done that, now we're ready to hook this up. So if you're looking in, this is, whoa, that's supposed to be a straight line. Oh boy, let me fix that. I got a little bit crooked. There we go. So if you're looking the way we have it, two glass doors, you have this one slid over, but up top on the right there is a shelf, the highest shelf there is. So what you're going to want to do is you got your little beaker, everything there, is there's a pipetter that reaches down, a pipette I should say, that reaches down, and it's connected to a hose which, unless things change, should have some kind of red or pink tape on it. That's how we designate what column it's feeding into. And that hose goes down then and connects to our red column. There'll be a blue cap, and so you just connect it into the blue cap. And it's obvious which one's the red column because, well, it's red. You want to make sure that there is some kind of headspace with the buffer in it. This should have been already equilibrated with our buffer. And by the way, at this point, the buffer, I'm just going to write what it is. The buffer that's in the red column should be 10 millimolar tris, whoops, that's a tris, pH 8.6. And you should be able to find some of that buffer made. Oh, and by the way, here's the rest of the cooler setup. Okay. And to begin with, you just let this flow until and collect it in a beaker. And if everything's working right, our protein should be stuck to the column and the rest of the protein should flow through. Now, sometimes this thing is running on gravity. It's using siphoning. Sometimes what happens is the siphon can break, meaning that you have to get liquid up and over this part, and once you do that, it will naturally flow and keep flowing as long as this is below that beaker system. Now, you may have to disconnect this, and usually, matter of fact, I'm pretty sure it's still there, there's a shelf, a little half shelf in the back, and you might see a small syringe. It should be there, about a 10 mil syringe, and you just simply plug it into the hose here and draw some liquid so it goes. The key is it's got to go up and over and start flowing a little bit, and then reconnect it right away, and then let this flow until this guy completely is empty. Okay, then, and this column typically runs pretty fast, so you got to pay attention to it. You don't want it to run dry. And then nearby have some of this tris buffer ready to go, so that once you've delivered all of this protein sample, you can just pick up this and put it right into this buffer. And the idea then is you're going to let it flow until a few hundred mils come out. And ideally what this is doing is washing any protein that has not stuck on the red column off of the red column. Ideally, that protein will not be our protein, but the contaminating proteins. And we wash it really well. When we're done with this wash, that's when we do the next phase. Okay? And the next phase, I think what I'm going to have you do, we'll either use the fraction collector if I'm around to show you how to use the fraction collector. But in the event that I am not around, then I'm going to have you do a different method. Okay? So I'm not going to show you how to set up the fraction collector through this video because I just think it's a little confusing. And so if I'm not there and you are doing this and I'm not there to show you how to use the fraction collector, if you don't already know how. So if you do know how to run the fraction collector, then you could hook up the fraction collector to the bottom of the column, set this aside and save it until we know we have purified protein. If you know how to use the fraction collector, because if you used it before, then hook it up and do what you've done in the past. But since we know that this protein is largely going to be our protein, then what I'm going to have you do in the absence of a fraction collector is to get some smaller Erlenmeyer flasks or even some beakers, which is fine. And actually, yeah, that's what I'll have you do. And what I'll have you do is collect, well, wait, I got ahead of myself here. So once we've done the wash, okay, we're ready to elute. And that's, the elution will involve this buffer. The elution buffer is the 10 millimolar tris pH 8.6, so that part's the same, but we add one thing to it. We make this so it's 2 molar sodium chloride. Now, if there is no 2 molar sodium chloride supplemented buffer, you're going to have to make that. And we have tons of sodium chloride, and all you do is take some of this buffer and add enough sodium chloride to make the, maybe 500 mils or something like that of this buffer. 500 mils is probably enough. In fact, you use far less than that in this process. But you'll probably find some made more often than not as part of getting ready for these column preps and stuff. We make some of that. But if you don't find it, that's something we'll have to work on. Okay, I'm yawning because it's in the morning when I'm making this video. So what you'll do then, when you're ready to elute, you have to either have this hooked into the fraction collector or find yourself, some smaller beakers or these Erlenmeyers, and you're going to collect fractions in these. So what I'm going to suggest you do is say collect 25 mil fractions in each of them. So you'll estimate 25 mils, doesn't have to be perfect. So what you'll do is get these ready, put them underneath here, replace this guy right here, and you will have your buffer, your elution buffer. I'll put this elution buffer. By the way, you don't have to have them in order like this. You're going to have to move these forwards to make room because I don't think the hose can reach. You'll just replace this one where it's located with the successive ones. So the elution buffer, then you'll hook it in and collect what comes through, say about 25 mils per thing. So, just do something like that. And the challenge might be, and this is maybe something you could do if you want, what you could do is rather than collect directly in these containers, you might go find yourself a graduated cylinder. We have a 100 mil graduated cylinder, and collect 25 mils. In fact, that's what you could do that. Collect 25 mils in the graduated cylinder and then pour it into each one of these. And the first one you'll label 1, pool 2, pool 3, and so forth. So if you can get that far, somewhere in there is going to be our protein. And then once we find it in these different pools, we can combine the pools with enzyme activity, and that's going to be our working enzyme stock. So that should do it. You can test by doing assays. So you can assay for which pools contain carbonyl reductase activity, and if you don't know how to do the assay, then you're just going to stop right here. But if you do know how to use the assay, then that's what you're going to do. So there you have it. That is how we run the red column. And remember, this step is, you only do it this way if I'm not there to show you how to use the fraction collector. I just feel that that takes a little bit more one-on-one, either via Zoom or in person, so I can kind of get you to walk through it. But I think this way works really well, because all we're doing when we hit it with 2 molar salt, we're just bombing it off the column, and that should be adequate for what we're doing. Okay, so that is how you'd run the red column.